Batteries are a familiar part of our lives, powering our devices and providing portable energy. But what if I told you that Elon Musk, the renowned entrepreneur, is working on something extraordinary? He is developing a monstrous battery with a lifespan of up to 28,000 years, capable of converting waste into energy. This innovation opens up intriguing possibilities, including the potential use of nuclear waste to power a continuously running battery. But how much energy would it take to recharge such a battery, and what impact could it have on our future? Let's delve into the fascinating world of nuclear diamond batteries and explore their potential together. Welcome to Revel Technology, where cutting edge meets limitless potential in the world of innovation. You know what batteries are, right? Well, guess what? Elon Musk is actually working on a super powerful battery that can last for a mind-blowing 28,000 years. It's pretty amazing to think about harnessing waste and turning it into energy. But here's an interesting thought. What if we could use nuclear waste to create a battery that never runs out of power? How awesome would that be? I wonder how much energy it would take to recharge it and how long it would actually last. Recently, there have been these things called nuclear diamond batteries, or NDB, that have hit the market, and people are buying them like crazy. Can you believe that even Elon Musk, the richest man in the world and the titan of innovation, might be one of the customers? He has actually talked about this kind of energy before. I wonder if he's considering using NDB in his future projects. Well, I won't spoil it for you just yet. Keep watching until the end of the video to find out. Imagine never having to charge your phone or laptop again because they run on one of these batteries. But let's think bigger. Imagine a spacecraft powered by this revolutionary battery. It has the potential to transform not only the technology we use on Earth but also in space, including future cars and life-saving medical equipment. However, it's not without its flaws. Like anything else, the NDB has some limitations. For one, once it's implanted in a device, it's hard to remove and expensive to create. But the most important concern is that it produces radioactive waste, which can be hazardous to dispose of. Back in 2016, scientists, physicists, and researchers from the University of Bristol started working on a radioactive diamond battery, which they called a beta-voltaic device. Basically, it's powered by the beta disintegration of nuclear waste. This process, known as beta decay, releases particles to maintain a stable balance of protons and neutrons in an atom's nucleus. These particles create beta radiation, a type of ionizing radiation that includes beta particles or positrons. So with this battery, you wouldn't need to plug it into a power source because it's constantly exposed to beta radiation, allowing it to recharge itself for an incredibly long time without noticeable degradation. It's not just a few hundred years, but potentially thousands of years. That's absolutely mind-blowing. So, what do you think about all this fascinating information we've shared so far? If you're enjoying our video, don't forget to hit that subscribe button and give it a like. Your support really goes a long way in helping me grow the channel and bring you more awesome tech content. Now let's dive deeper into energy conservation and Tesla's role in it. When it comes to energy conservation, no one does it better than Tesla and Elon Musk. They are the industry leaders in the shift towards electric cars, and that's why we are focusing on them. But let's think beyond the current lithium-ion batteries that power Tesla vehicles and our smartphones. There must be a better alternative out there. Let's put this battery's lifespan into perspective by comparing it to the everyday products we use. It will give us a better understanding. The NDB battery is estimated to have a usable life of 90 years as a car battery, which is much longer than the average lifespan of any vehicle. Just imagine one battery could potentially power multiple cars throughout their entire lifetimes. On the other hand, a consumer electronics battery for a tablet or smartphone is expected to last around 9 years. Now let's dig a bit deeper and get into some additional information because I want to make sure you have all the right and detailed knowledge. At its core, a battery is a device that converts stored chemical energy into electrical energy. It does this by facilitating the transfer of electrons from one material, known as the electrode, to another material through an external circuit. This transfer of electrons generates an electric current that can be used to do work. On the other hand, the diamond battery operates on a different principle. It is a type of beta voltaic cell, similar to photovoltaic solar cell. Instead of converting light into electricity, it converts beta radiation into electricity. A typical beta voltaic cell consists of layers of semiconductors with thin layers of radioactive material in between. When the radioactive material undergoes decay, it releases beta particles. These particles then collide with electrons in the semiconductor, creating an electric current. However, there are some challenges with beta voltaic cells. The power density of the radioactive source decreases as you move away from the semiconductor. Moreover, beta particles are released in random directions, so only a tiny fraction of them will actually reach the semiconductor and convert into electricity. This results in a lower efficiency compared to other types of batteries. To make these NDB batteries possible, polycrystalline diamond or PCD is used. Diamond is an incredibly hard material, even harder than silicon carbide. It has the unique property of being both a semiconductor and a source of radiation. This allows for the creation of a battery that can last a long time without the need for recharging, thanks to the beta radiation it is exposed to. The radioactive waste housed inside the battery keeps it charged indefinitely. The process of creating synthetic diamonds for these batteries is known as chemical vapor deposition. It involves using C14 methane and hydrogen plasma at high temperatures to produce diamond sheets. The diamond used in the battery is much smaller than the ones we see on jewelry, consisting of thin layers of large crystalline grains. This multi-layer construction also serves the purpose of containing the radiation and reducing any potential health risks when the battery is used near or even inside a body. So there's no need to worry about any danger to people. However, the manufacturing process of these unique diamonds creates a cost barrier for NDB. Producing diamonds with the required properties is expensive and energy intensive. Diamonds are known for their high heat conductivity, making them ideal for electrical components. They are 3 to 4 times more efficient at conducting heat than copper or silver. Natural blue diamonds, which are often used in NDB, are rare and much more costly compared to their synthetic counterparts. Once obtained, the nanodiamonds are combined with radioactive isotopes derived from nuclear waste, particularly uranium and plutonium isotopes. The tiny single crystal diamonds, measuring just a square millimeter, efficiently transfer heat away from the decaying isotopes, generating power in the process. The final product is a diamond with a level of conductivity much higher than regular diamonds. While the recent mentions of nuclear diamond batteries are associated with NDB and the University of Bristol, in collaboration with Arc and Light Research, the development and testing of beta voltaic cells have been ongoing for several decades. The popularity of first-generation nuclear batteries declined as more affordable lithium batteries entered the market. However, Elon Musk has expressed concerns about the processing of lithium-ion batteries. Despite having the necessary resources to produce lithium-ion batteries, processing lithium carbonate or lithium hydroxide is challenging. Currently, China dominates the lithium-ion battery market, producing nearly 80% of the world's batteries. If China continues to control the market, exploring alternative paths like NDB might be a preferable option. Tesla's ambitious plans are taking shape with the construction of their new gigafactory, providing ample space to advance the development of nuclear diamond batteries. In fact, the company has recently struck a deal with an Australian firm to directly source materials for their batteries. While many companies are eager to join the race in developing these batteries, their current use case is quite limited due to a significant drawback. Despite their ability to operate for extended periods without recharging, these batteries have a relatively low energy capacity. As a result, they can only power relatively small devices that don't require a significant amount of electricity, which restricts their applicability. At present, diamond batteries are suitable for powering small electronic devices like hearing aids and smart watches. Individuals who require hearing aids from an early age would greatly benefit from this technology, as they would only need one operation and could use the device without interruptions. If Elon Musk were to have even a fraction of faith in NDB batteries, the potential for Tesla would be limitless. They could be miles ahead of any other energy company globally, provided the concerns surrounding these nuclear batteries are addressed and resolved without adverse consequences. While this concept sounds fantastic in theory, its practical implementation is more challenging than it appears. The utilization of nuclear energy requires utmost care and caution. However, this idea has the power to fundamentally transform our perspective on energy and sustainability. With the pressing issue of global warming escalating each year, both our future generations and ourselves, it might be high time to embrace intelligent energy solutions. Elon Musk currently possesses the means and the responsibility to lead the way. What are your thoughts on Elon Musk's monstrous battery that can last up to 28,000 years? Do you believe this revolutionary technology has the potential to reshape our energy landscape? Engage with us by leaving a comment, subscribing to our channel, and clicking the notification bell for regular updates. Keep watching, stay inspired, and get ready for more exciting discoveries. See you in our next episode. Batteries are